All right, ladies and gentlemen, let's go ahead and get started here. This is going to be PA lesson 6-5, and today is just going to be an introduction to inequalities. Now, this lesson in your book is actually adding and subtracting using inequalities. There's actually no review for the basic concept of an inequality. So today what we're going to do is we're going to just review the basic concepts that you're going to see or have to use in your homework. And then what we're going to do is I'm going to give you an assignment that you can work on tonight. It's due at the end of the hour. And then your homework, I've already given you for the weekend. It's on the board over here. And so that's due Monday, but everything you need to do that we'll learn today. So if you wanted to get it done early, I would recommend it. Then you have no math homework for the weekend. But that's on you.
What about Friday?
So that'll be tomorrow's assignment on the board. All right, let's go ahead and get started here.
Well, we get an assignment today then.
You are getting a separate and different assignment today, yes. But you'll have all hour to work on it once I'm done with this.
So it'd be like half an hour.
Right. All right, when you're working with inequalities, the whole point of an inequality, Mr. Brooks, is so that you can have a large group of answers. Typically in mathematics, you have two scenarios. You have a single answer, so like 2 plus 2 is 4. And then you have a scenario where you might have everything larger than 5 is an answer, okay? So let me show you what this looks like. I'll draw all 4 scenarios here. These are just representations. So you might have something where it says x is greater than 3. Would 4 be a possible solution to this? Could 4 be greater than 3?
Yep.
Yeah, what about 5? Any number greater than 3 is a solution here. There's an unlimited number of answers. Okay? This is tricky, right? The point that we have to kind of try to figure out is how do you write an unlimited number of answers, but yet it still has to fall within certain what we call parameters. Okay? Because you can't just use infinity because 3 is not an answer, 0 is not an answer, but 4 is. So that's one way to write an inequality. The other option is that x is then greater than or equal to 3. Okay? What's different about this one, David?
The answer could be equal to 3 as well as bigger.
Right. So now we've introduced one additional piece of information, and that is the answer could be equal to 3. Okay? So we put that little line under the inequality. All right. The next two are pretty straightforward. I'm going to use a different variable here, however. Y could be less than 3. And then the next one is y could be less than or equal to 3. There are only 4 scenarios here. Okay? Greater than, equal to, less than equal to. Okay? I'll write them down here. You have greater than, then you have greater than, and I don't know why I said greater than.
It's all right. It's born out.
Yeah, thanks, man. Greater than, equal to, and then over here we have less than, and we have less than, equal to. Okay, so this is kind of what we're dealing with as far as possible answers. There's really 4 different scenarios. So let's go ahead and look at what we would call graphing these, because the best way to represent this information is to graph it. And I'm not talking on an actual graph. What I'm talking about here is putting it on a number line. So on your paper right now, why don't you go ahead and draw 4 number lines, okay? 4 of them. You don't need to put numbers on them yet. So they really just need to be like that. And I'm going to go ahead and make 4 of these.
How big do they have to be?
Big enough that you can draw something on.
Right. That's probably the best answer to that question. Okay, so I have 4 of them. And I'm going to go ahead and draw the 4 different scenarios here. So let's say that we're working with, and I'm going to put this in the upper left-hand corner. Let's say we're working with x is greater than 3. Okay, so on my number line, I'm going to put a 0. I'm going to put a 3. Does anyone remember from last year how I'd represent this? Does anyone remember how you would represent something like x is greater than 3? Yeah, Casey?
You go 3 and then you go like out.
Yeah, okay. You go to 3 and then you go out. He's in the right. But do you remember what we put like near or on the number line? Yeah.
Wasn't it like a filled or like a filled circle?
Yeah, it's kind of like little circles. Yeah, so the way it would look here is because it's not equal to 3, it's what we call an open circle.
Oh, man,
Okay.
last year.
And then there's an arrow attached to that circle. And the arrow always goes in the direction of all of the possible answers. So in this particular case, 4 is an answer, 5 is an answer, 6 is an answer that would make this true. All of those numbers are to the right on the number line. So we go ahead and we just draw an arrow to the right.
So why is it an open circle?
That's a great question. It's open because it's not equal to 3. If the answer was x is greater than or equal to 3,
So there would be like a little line underneath.
exactly. If there was a little line under the alligator mouth or the symbol, then it would be a filled in circle. Okay, and we're going to do that one next. So, leading into that, that's great. We have x is greater than or equal to 3. I'm going to do the same kind of stuff here as I did before. Okay, so we're going to put a 0, we're going to put a 3. This time, the only difference is instead of having an open circle, I have a closed. And what that tells me is that 3 is a possible answer to this problem. If it's open, it tells me 3 is not a possible answer. Okay, so I have 2 different ways of distinguishing whether 3 is included or not included. And it all comes down to whether there's that little line underneath the symbol. Any questions about this before I go on to the next 2? Any questions? Kind of just reviewing, trying to get some of these thoughts rolling again from last year. All right, I'm going to do the next 2 in green here. Y is less than 4. Okay, Y is less than 4. So I'm going to go ahead and I'm going to draw my 0. I'm going to put a 4 on here. Okay, how would I represent this one? Using what you've seen me do so far, how might I represent y is less than 4? Dylan? Okay, definitely going to have an arrow going to the left this time. Very good. That is correct. What else? What kind of circle might I include here? Casey?
An open circle.
It's going to be an open circle. So open circle because it's not including 4 as a possible answer.
Everything I said.
And then Whitmer, left or right arrow? Ah, very good.
You talk like that.
And the arrow doesn't have to be super long. I just have to see the direction. So you can conserve on graphite, aka pencil lead, or ink if you're a pen preferer.
I prefer
Okay.
pens, man.
Okay.
Nice and slick.
I hate pens.
Alright.
All right. Y is, hey, everyone cares except you.
Whoa!
Okay, y is less than or equal to 4. What's the only difference here? Mr. Blair, how am I going to represent this? What's different about it? I got to color the little circle in. Are you sure? That's the only difference. Be confident. Yes or no?
Yes.
Okay, that's good. That is the only difference. You were second guessing yourself there for just a second. Yeah, because the little line is under the inequality, I fill in the circle. And I color in the arrow. Any questions about this? All right. That's the end of the basics, the introduction. Okay?
So now on to the